Day of history and hope.
Assalamu alaikum warahmatullahi wabarakatuhu. Welcome to Open Forum from MTA International USA Studios, a space where ideas meet dialogue and questions of today shape the answers of tomorrow. In each episode, we will look into some of the most pressing, fascinating, and perhaps challenging questions of our time. Our aim is to break this down so it's very understandable and hoping it creates a dialogue. So let's begin. When we think of self-driving cars, you picture driving down the street, looking at the car next to you, and there is no driver. How is that car making sure that it doesn't hit other cars? How does it see kids on the road? How does it manage? And there's massive computers behind that. All the decisions that you made in your mind are now being made by the car. As well as we think about the ethical issues, the loss of safety and control. There's a lot going on. And guess what? There are actually self-driving cars on the road today. So what does this mean in practical terms? We're going to talk about the technology, the impact, and how does it actually work. I have with me today Imran Hayee. Imran Saab is the professor of electrical engineering at University of Minnesota Duluth. He went to school at University of California, and he worked at Bell Labs in wireless communication and signal processing. I'm sure we'll get into that in a little bit. He worked on optical fiber communication to wireless communication to intelligent transportation systems. And he teaches a course on signals and systems, and we'd love to get into that. But before we do, let's take a more in-depth look into our topic today.
Self-driving cars sound like the future, but it's already happening. They might not be fully everywhere yet, but they are real enough for you to take seriously. Here's a quick breakdown of how a car drives itself. Cameras. These are the eyes. Radar feels the distance and speed of nearby cars. LiDAR shoots tiny lasers to create a live 3D map of the world. AI, the brain that watches millions of driving situations and learns patterns. So, the car isn't just seeing, it's predicting what might happen next, like the cyclist might turn or the car might brake. Different companies employ different strategies, such as Tesla, just cameras, learn like a human. Waymo and Cruise, use all sensors, be super cautious. Baidu, already running self-driving shuttles in China. They're all trying to answer the same question: can a machine drive safer than us? But there are real risks too, such as if the sensors somehow get blocked, the car might get confused. If AI has not encountered such a situation before, mistakes might occur. And as of now, humans still don't know just when to take over, at least not yet. Islam encourages curiosity, to learn, to test, to improve, and to use your knowledge to serve humanity. So the goal shouldn't be just to make cars look cooler. Rather, it should be to make travel safer and more easier for everyone.
Jazakumullah for the brief and concise explanation. Let's dive into self-driving cars. First of all, what is a self-driving car? And I assume there's different levels of self-driving cars?
That is correct. When we say self-driving car, that really means that a car can drive itself without any human intervention. So the question is, what are various driving functions? So it's braking and acceleration, and it's steering control. So if all of these functions can be performed without any intervention from the driver, that's truly a self-driving car. But are there any...
And that means there's no one in the driver's seat, and all that is happening.
That is correct.
Okay.
A true self-driving car will be that no one will be in the driving seat. But do they exist? They don't these days. So technically, there are many aspects of self-driving cars at various levels which do exist today, and we are very familiar with that.
So what are the different examples of the various levels of the automation in the market today?
So you're right. Level 0 is cruise control, conventional style. In many old cars, it has it, but that doesn't maintain distance from the car ahead of it. That's called adaptive cruise control. Okay. And that would be level 1. In principle, level 1 means only one of the functions, either accelerating, brake, or steering control, can be performed by vehicle itself without human intervention.
So from level 0 to 1 in the first example, cruise control without adaptive, like when there's a car in front of you, the car slows down and speeds up. Now when you add that feature where it adapts to the car in front of you, and you have one feature, it's level 1.
That is level 1.
Does that exist today?
That does exist. Many actually, Hondas and Fords, they do have adaptive cruise control. And some of them actually have a lane keeping feature also. They give you a nudge when you're getting out of the lane. So that's also level 1.
And that's a great safety feature too.
That's a great safety feature too.
I see.
So automation ultimately is supposed to make driving safe. This is the ultimate goal. It's not only to save time, but also to make them safe. In reality, when all cars on road will become truly driverless, it will be much easier. The real example or comparison is rail system.
And tell me about that, because it's safe, it's very helpful to all of us if we fall asleep or do something that's not appropriate. How does that work? How do you get that there?
So lane keeping features, they work in majority of the cars. They have it actually, middle range vehicles. So they are camera based. So there are multiple cameras in front of the car. They take pictures of the lane markings. So they compare frame by frame, and then by comparing, they figure out if the lane has been shifted, lateral distance. So based upon that, they decide the lane has been changed, and then they nudge the driver.
So level 0 is the old cruise control without adaptive to the car in front of you. You've got to hit the brakes. Level 1 adds one feature such as adaptive cruise control, where you can see the car in front of you and the car automatically slows down or speeds up according to the space that they have. How does that work?
Most lane keeping features work on camera-based, vision-based systems. They do have sometimes LiDAR also, but they take pictures of lane markings.
What is a LiDAR?
LiDAR is light-based radar, laser-based radar. It works like a radar, but not RF signal, radio frequency signal like wireless signal, but rather a light signal.
And light is faster than radio frequency?
They both are same speed. Okay. The difference is that how quickly the signal change in that. The frequency is much, much higher. It's close to the frequency which human can detect, the light, but it's slightly different. So we don't see it, but actually it is there.
So there's different ways to get this signal.
There are various ways to get those signals, but the main idea is that the pictures are taken of lane markings, and they are compared frame by frame to detect if a lane has been shifted, and that's the prime feature. Sometimes if the lanes are covered with something like snow covers lanes all the time in Minnesota, sometimes they are worn out in rural areas. So camera-based systems do not work. They have the limitations. We developed an algorithm which uses GPS technology to detect the lateral shift on a lane without relying on lane marking.
GPS is like global positioning satellite?
That is correct. It is global positioning satellite which tells you where you are in a given space on a road. It does give you an error when it tells you your position on a road. An error could be between 2 to 5 meters. And that is not sufficient for lane shift, because lane itself is about 2.5 meters or so. So However, if there is an error in lane position, this error remains the same in the next position and the next position. So the relative error doesn't really move that much.
So this is how, I mean, a simple feature, it seems like it exists in a lot of cars now. It's super complex to build, and you worked on this.
Yes, I worked on this. This algorithm was developed by myself and my team of graduate students. And you can see the graphic on screen. So this was the field test which we did. And you can see in the middle of the car, there is a camera which is just recording a lane. So we can see if
the phone that's on the
lane
left,
has
yes.
been shifted, left or right.
Okay.
So when lane shifts, the app which we developed, which uses our algorithms, can tell us, can audibly warn us as well as show us that the lane has been crossed. So that is basically a field test picture which we did.
That's incredible, and it is literally, inshallah, saving lives and helping people stay alert and stay in lanes and avoiding accidents.
That is correct, because this is for unintentional lane departure. Sometimes you're tired and you're drowsy, and you're going on a long freeway, and nobody's around, and you can doze off, and that's really the main. Sometimes you're under influence also, and that matters as well. So if your steering is moved a little bit, you can go off track, and that can cause serious accidents.
And so this is preventing a lot of unintentional lane departures. Let's go to level 2. Now, this, from what I understand, there's a lot more that's available now in the marketplace.
Level 2 is basically where steering control as well as braking and acceleration can be controlled by the vehicle itself without human intervention. However,
you still need a driver in the car.
Still need a driver in the car. The reason is that those systems are not perfect, and they can hand over the control to the driver at any time.
And who's doing this today?
Tesla's autopilot, majority of Tesla's cars, which people understand they're full driving, self-driving systems, they are not. They're actually level 2.
I see.
And similarly, there are...
but it's pretty impressive.
It is still pretty impressive. However, the human has to be there. There is a driver's seat, and in many of such systems, the hands of the driver has to be on the steering.
I see. But it can see traffic lights. It can notice a red light versus a green light and stop. It can see if there's a child going across the street and stop.
Yes, actually, that's how a self-driving car works. That it has a lot of cameras at various places as well as LiDAR systems. LiDAR is basically light-based radar, so laser-based radar. So it actually scans around the vehicle and can see the environment as well as in front. And based upon all that data, so there is a decision-making happening within the car. And that decision-making is done without the driver's intervention. So what is happening is that driver's eyes are simulated with all those sensors, cameras, and LiDARs, and then brain is simulated decision-making, which is decision-making is simulated.
How many decisions are being made? Because there could be a child on the right, there could be a light in front. Is this billions of decisions happening every minute?
That is correct. If you are driving, human mind works very differently. You make millions and perhaps billions, depending upon how long are you driving, of decisions in your brain without knowing.
Right.
So this is the biggest challenge in self-driving car. To make huge number of decisions is not easy. And sometimes, for example, you see somebody sitting on the crosswalk, and you kind of can perceive if that person is going to cross the pedestrian lane or not. So based upon that, you make a decision without knowing. But this is a big challenge for self-driving car.
And going back to some of your research, this idea of a signal. Now you mentioned LiDAR versus radio frequency, but these are all signals and sensors. Is that how I should understand it?
That is correct. They are signal. When we say signal in terminology of electrical engineering, that means electronic signal. But that doesn't mean that we are not connected with the real world. Actually, there are sensors available, which technically are called transducers. They can convert any physical phenomena to an electronic signal. And that basically physical phenomena that either is an image or a video, or it's basically something is moving or some structure they can see. So based upon those electronic signals, a vehicle can understand who is there and where they're standing.
It is just fascinating. I didn't recognize one of the things is just being able to find where the red light versus green, where the light is, and stopping on red may be easier, but just finding the light in thousands of different crosswalks around one city could be super complex.
It is super complex, and actually, when there are a lot of roads when there are a lot of cars on the road sharing with you, that's basically a huge problem. You do not know who will be cutting you off, who will be going straight. So this is not easy for a self-driving car to decide.
So I understand level 2. Now help me understand level 3. I assume there's more and better.
That is true. There's more and better. However, driver's seat is still present and driver has to be there. However, driver can relax a little more than they can relax in Tesla's car.
What's the difference?
The difference is that level 3 is designed for specific areas and specific highways. And if you're outside of that region, level 3 doesn't work, and then driver has to be present. So that's the main difference.
And it seems like the complexity is there are so many miles of roads, even in one city, and all the turns and signs and everything, it really needs to be mapped over and over. And we've seen that. Looks like some companies have billions of miles on the road, while others have less.
That is correct. For example, Tesla claims that they have billions of miles. Actually, 9 billion recently, they claim that they have completed 9 billion miles.
And they're collecting data from every one of those miles and making decisions?
They are collecting data, of course. Some of the miles they show, they boost about to gain public trust also. We can talk about that later. But there's one important point to be made. Majority of those miles are on freeways and highways. And the last mile, I think in this context, they say last mile, or similarly the first mile. When you take the exit, you get into an urban area, that's the challenge. And especially at nighttime when there's traffic, of course, in New York City, for example, there's still traffic and lighting is not really as good. So urban areas and also tall buildings, which can disturb GPS signal. So there are many things involved.
So there are signals involved. And do the cars talk to each other in this level 3 to stay away from each other?
Cars can talk to each other, but it has nothing to do with level 3. Level 3 in itself is that driver has to be there, but a lot more independence.
Higher confidence.
Higher confidence.
I see.
Now, where is not driver with self-driving car supposed to be not having a driver, and that's only in level 4. And level 4 means Waymo's taxis in San Francisco, in Phoenix area, that is truly level 4. And similarly, Beidou, a Chinese company, has a lot of level 4 taxis within China.
So now I've been in one of those. They're pretty spectacular, but there's no driver.
There is no driver.
And they've mapped that city like San Francisco. It's pretty small city, but they mapped it.
There is a reason they only work in San Francisco, Phoenix, and I think they're trying to extend to some other areas. The reason is that they have to map the city well. The high resolution maps, it's not only that where you are on a road, but rather which side of the lane, given lane you are, right side of the lane, left side of the lane, and also relative to you, where is everything within like a centimeter resolution. That's why it's make it very challenging. And they only work in those specific, very, very specific areas.
That's interesting. And from what I understand, level 5, what is that? And it's still a dream?
It is a dream. A level 5 does not exist right now. And as a matter of fact, level 4 is not mature enough either that they can talk about, they can, move to level 5. First, level 4 has to be mature enough so that actually it can be available widespread for a lot of areas.
I see. Now, what are the technological challenges still not solved? It seems like a lot of people have been working on this for a long time. What are the technological challenges?
So technological challenges, there are various technological challenges. The first one is that when you see something, using cameras and sensors, they don't always work. They can fail. So red light, green light, sometimes you can miss. There's a possibility. There have been the high-profile accidents where a vehicle failed to detect somebody. For example, the first accident was in 2018 where a woman was pushing her bicycle and Uber's self-driving car could not see and actually killed that woman. And that was the first high-profile accident of self-driving cars. So similarly, Tesla's, I think in a few years ago,
right?
Tesla crashed with a trailer.
So what goes wrong? The signal? Is it the signal? Is it the speed? Is it the braking?
So it's also environment. Means sometimes lighting condition is such that sun is at this position that they cannot see. That was white color trailer and it was mist. So these things happen.
Let's pause here for a second because I know everyone has an opinion on this. Some believe it's greatest thing since a long time to come to make lives easier in our commutes. Others are still struggling with it. We're going to go to the street and hear directly from the American public how they're feeling about this.
Assalamu alaikum wa rahmatullahi wa barakatuhu. We're here in the heart of New York City at Times Square today to ask various people about their opinions on these new technologies that are coming out, whether that's self-driving cars or AI in general. Let's find out what people on the street are saying. All right, we're standing here with our friend Chris. Chris, what are your thoughts on self-driving cars in terms of Waymo and Tesla and those other technologies?
I think those are the game changer, and this will truly change the way people travel in the future.
Well, the AI is going to be helpful for like identifying like people, the cars, be smarter and avoid like collisions.
I've never been in one, but sounds interesting. Maybe less crashes.
Do you think these cars are safe? And if there's an accident, who do you think is to blame?
Well, this is a big question, and but in general, you have to admit that it's a lot safer than human drivers. 7 times more safer than human drivers.
Right.
If there is an accident, I think the car company has to be held accountable.
The company,
The company?
the company behind the AI.
I mean, if there's no driver, it would be the person responsible for putting the car out there, I think.
Okay, got it. Well, that's all the questions we have.
So that this video, clearly the public has some concerns on how will this impact their neighborhoods and this technology coming into their neighborhood. And it seems like these cars, now there's not a human driving, there's a computer driving, and this computer is could be connected to the internet, it could be connected to all the other cars to make sure it's safe, it can be connected to various things. How do I make sense out of this?
So I think one of the reasons of the public mistrust on this is potentially because vehicles are connected with the internet. So many a times, many things are decided, many decisions are made in cloud. Although it has to be done very quickly. So there are issues which public has about hacking, about spams.
So someone else can take over my car when my kids are in it is not a good idea.
That is one of the major concerns they have it, because
Sure.
they see their internet, computers at home all the time, they get viruses. So what about a virus comes? Somebody with evil-mindedness can do that. So security is an issue, privacy and hacking. But there's another technology which is connected vehicle technology. And this is different than the self-driving car or autonomous vehicle technology. The way autonomous vehicle technology works is relying on sensors to detect something is in the middle of road, for example. Maybe a tree is fallen in the middle of the road. Autonomous vehicle technology can understand, can see that. Connected vehicle technology cannot see that. However, connected vehicle technology can send a signal to the car that I'm around the corner. You cannot see, but I'm around the corner.
Oh, interesting.
Which is basically that is why that connected vehicle technology and autonomous vehicle technology, they
come
need to
together.
marry each other to make sure that widespread deployment of self-driving cars.
Tell me more about this connected vehicle technology. This is fascinating.
Connected vehicle technology basically works on a very specific RF spectrum, which is basically signals, very special signals, dedicated signals, where vehicles can talk to each other. Again, there are systems, there are firewall and security protection, various kind of encryption is there to make sure that no hacking can happen and nobody can introduce any virus.
And pictorially, I know we have a graphic to show this as well.
Yeah, that is correct. Actually, if you see the video on the screen, what happens is that those vehicles are going and there is, the LiDARs are scanning their environment. And as well as you see the lines which are connecting the vehicles with each other, that is the connected vehicle technology. Means signals are being transferred from one vehicle to the other vehicle to carry the information. Actually, one vehicle can tell the other vehicle that, my position is this, for example, relative to you, and vice versa.
So let's bring this together. I mean, there's a lot of promise here. Tell me where this is going. In the next 2, 3, 4 years, what should I expect to see? Where is this technology all coming together and going?
I think the real expectation is that it's much easier to enable self-driving vehicle features on a freeway. But after you take an exit, it becomes very, very difficult. So I think they will, just like high occupancy lanes right now for faster speeds or, basically more people, they could be dedicated lanes. You can expect that self-driving cars can go there without disturbance, and that can save you a lot of time and can buy you peace of mind. But as soon as you take the exit, you still need to take the control. It means in near future, I do not see that the driver seat is going to go away.
Thank you. Thank you for taking the time for sharing the self-driving features. We learned about connected vehicles, we learned about signals, and we learned about different levels of self-driving cars. Now, going in a car without anyone in the driver's seat is in very few places right now, but it's coming. And there's a lot of challenges, as Imran Saab has shared, but there's a lot of promise here, and we look forward to you experiencing this for yourself in the near future. That brings us to the end of today's open forum. Our goal is not just to provide answers, but to speak and spark questions in you as well. And hopefully you will go explore this, because there is a lot of depth in this topic. Thank you for joining us, and we hope to see you again soon.